Hey, welcome back, students. We're going to go ahead and look at some sample problems now from the ideal gas law section. And in order to get started with these questions, let's just go ahead and look at the problem that we have before us and underline the parts that are important for us in terms of variables. So the problem reads, we have a gas system that is found to have a pressure of 1.16 atmospheres, a temperature of negative 44 degrees Celsius, and 0.370 moles. And you're being asked, what is the volume in milliliters of this system? So here's what we know. So let's underline what we've got. We've got a pressure of 1.16, we've got a temperature of negative 44 degrees Celsius, and a moles of 0.370. So here's my N, here is my P, this is my T, and they want us to figure out the volume, right? Here's what we're looking for, the question mark. And so if we look at this, the equation that we've got here is we're going to use PV equals nRT. Remember from previous discussions that R was actually equal to 0.0821, and this is going to be atmospheres liters per Kelvin mole. So we're going to take this coefficient, or this constant, and what we're going to do is just plug it into the equation with everything else we want. Since we're trying to find volume, let's just go get our equation in the format that we want. So V is on the left-hand side, and we want it by itself. So in order to get V by itself, we need to divide by P. And so the equation that we're going to use, modified that is going to be V is equal to nRT divided by the pressure. So this essentially, I'm just going to go ahead and rewrite it over here. And that's going to be volume is equal to N, in this case 0.370 moles, multiplied by 0.0821, and I'm just going to leave the units tiny here, atmosphere liters per Kelvin mole, and I'm going to multiply this by the temperature. In this case it's negative 44 degrees, and so we're going to take that Celsius value and we're going to add 273 so that we can actually get the correct Kelvin number. And so the answer here for that is going to be 229 Kelvin. And all of this is going to be divided by our pressure value, which is currently at 1.16 atmospheres. So if you look at this carefully, what's going to happen here is our atmospheres are going to cancel, our moles are going to cancel, and our Kelvins are going to cancel, and so what we're going to be left with is our liters. So if we go ahead and do this, the volume that's going to be found to be here, if we do all this math, is going to be the following. So what we're going to do is going to take this 0.370 times 0.0821 times 229, and in the numerator we're going to get 6.956, and since everything is going to cancel up there, it's essentially we're going to wind up with this number. Our units is going to be in liters at the very end, and then we're going to divide this by 1.16, and if we do that, what we wind up getting here is an overall answer of 5.996 really, but we're going to leave it here, of liters. This here is the answer for this particular problem. Now, this is the answer if we're stopping at liters, but what does the problem actually ask us? The problem wants milliliters, so we're really not done here. So I really can't circle this and say, hey, we're done, okay, because some students stop here and we want to make sure that we actually get this right. So what needs to happen here is we need to take this value and we need to multiply it by 1,000, and when we do, that's going to give us a slightly different answer, and essentially this decimal needs to go 3 spaces to the right, so that'll go 1, 2, 3, and so our overall final answer should be equal to 5,996 milliliters. And that truly is the final answer for this problem.